Hello everyone, we recently implemented a cache system design using LRU eviction policy as a team of 3 members. I am Praveen and other 2 members are Pawan and Hemant. Let us look into the problem statement. Okay, this is the problem statement we look into. In this problem statement, we need a system to store limited amount of data or remove least recently used data when it is full. In this design, we can perform the following operation. The operations are put and get and eviction. In this put method is used to put a value against a key in the cache, and get method is used to get the previously saved value using key, and eviction is also support removal of some key in the cache when it is full. And these are the expectations that should follow while designing a cache system using low-level design. First one is code should be functionally correct, and next one is code should be modular and readable. And next one is code should be extensible and scalable, means it should be able to accommodate new requirements with minimal change. And next one is code should have good OPVs design. Okay, next we look into the class diagram. Okay, this is the class diagram. In this class diagram, this is the main class. Can act as a cache system to store and retrieve as key value pairs. And this is the storage to store data. And it can perform two methods. One is get method and put method. Get method is used to retrieve data, and put method is used to add the data based upon key value. And next, this is the storage interface. In the storage interface, it is a blueprint for storing and removing and retrieving as key value pairs. It can perform three operations. First one is put operation. It can add or update as key value pairs. And next one is remove. Delete a key value pair. And next one is get. It can retrieve a value for a key. And next, this is the eviction policies interface. In this eviction policy interface used for defining a rules for remove all data when it is full. It can perform two methods. One is key accessed. It can be used to mark the key as recently used. And next method is remove key. This can use it for decide which key to evict. And next one is LRU eviction policy implementation. It can be implemented by using double linked list. We can use double linked list to traverse the order of key usage. And next one is hash map. It can use it to map keys to linked list nodes for quick response. And it can use it two methods. One is key accessed and other one is remove key. Next one is hash map based storage. It can be based on key value pairs. It can perform the following operation. First one is put operation. It can be used to add the data. And next one is remove. It can remove the data. And next one is get. It can retrieve the data. And next one is storage full. It can check whether storage is full or not. Sometimes it can raise an exception. First one is storage full exception. It can be raised when storage is full, no space is left to add new data. And next one is not found exception. Not found exception is raised when try to access a key that does not exist. And these are the two exceptions. And next, double linked list node implementation. In this double linked list node represents a single node in double linked list. These are the attributes that are element, next, and previous. These are the methods. First one is get element. Retrieve the element from the node, current node. Next one is get next and get. And next, this is the double linked list. It can connect the double linked list nodes. These are the attributes. One is head and tail. These are the methods. First one is detach node, remove specific node from the list. And next one is add node to last. It can add node to the last, add element to last. And next one is empty. It can check whether list is empty or not. And next one is get first node and get last node. This is about the class diagram.
If you look into the file directory of our low-level design to implement the cache system, we have packages like cache, policies, storage, and our main function, and also the doubly linked list to implement the LRU cache. First, let us look into the cache class. Here, the cache is responsible for the operations or it supports the methods like put, get, and also remove the key when the storage is full. Firstly, we have imported the packages, eviction policy, and storage to integrate them into our cache class, and we created the private variable eviction policy and storage. In the cache constructor, we have initialized the eviction policy and storage, and in this put method, first before putting the key value pair into the storage, we will check whether the storage is full or not. If the storage is full, we will try to find out the key which need to be removed based on the eviction policy. And after removing this key which need to be evicted, there will be space to put the our required key value pair, and we will mark this key as accessed in the eviction policy, so that we can maintain the order of keys based on this access time. And in this get method, we will get the value of this particular key, and by dot get method, we will fetch the value of a key. If the value is not null, then we will return the value, and we will also mark the key as accessed. And now let us look into the storage package. Here we have implemented the interface storage with the hash map based storage class. In this interface, we have methods like put, get, remove, and also two boolean methods like contains key and to check whether the storage is full, etc. And the main reason behind this interface is, in future if you want to extend or if you want to implement the storage interface through file based storage, or if you want to use a database storage, you can directly extend with the implementation without changing the existing code. Now let us look into hash map based storage, how we implement it. And here we define a private variable called capacity of this hash map based storage, and hash map, and we have initialized this capacity variable and hash map in the constructor. On calling the put method, the value key value pair is put into the hash map, and by calling the get method, we will get the value of a key in the hash map if exists. And on calling the remove method, the key value and the this node is removed from the hash map. And here we used a boolean method contains key to check whether the key is present in the hash map or not. If it is present, it returns true, otherwise it returns false. And each full method is called to check whether the storage is full or not. If this is storage is full, it returns true, otherwise it returns false. Here we used hash map because of its time complexity of big O of 1 for the insertion, adding, removing, and fetch, and finding the key. And if you look into the policies, here we also define an interface for the eviction policy, and it contains methods like key accessed, evict key, and evict a specific key. And here also, when you want to use any other eviction policies like MRU or LIFO, etc., you can directly implement them with the help of this interface without changing the LRU cache. We can substitute this LRU class with the another eviction policy. And if you look into this LRU cache class, here the class is responsible for the LRU cache implementation, and we will use here a doubly linked list and a hash map, because in this hash map you will store the key value pairs, and as we already discussed, it provides a time complexity of big O of 1 for the insertion, deletion, and finding the key if it exists. And the doubly linked list is used to maintain the order of keys based on the access time. And in this LRU cache constructor, we have initialized the doubly linked list and hash map. And if the key is accessed, we will check whether the key is contained in the hash map or not. and if it contains, we will just remove that node and we will add, or we will put this key into the map. And if you see the evict key method, we will remove the element, which is at the tail, because we are using the LRU cache implementation. You can get clarity about this in when we discuss about the doubly linked list implementation on following video. And we'll check before removing whether the node is null or not. If it is not null, we will remove that node and we will return it. And this evict specific key method is used to remove a particular key. And let us see the doubly linked list. Here the doubly linked list node class is just a helper class for the doubly linked list, because it only contains about the details of node, and the node contains data and previous and next pointer for the navigation purpose. And in doubly linked list node constructor we have initialized this data. Let us look into the doubly linked list. Here we have the pointers previous and next, as well as the head and tail, which are the first refer to the first and the last nodes of this doubly linked list. With the help of this doubly linked list, we will maintain the order of the keys based on the access time. If you want to remove the node from the double linked list, we will use the following syntax, which we will not be discussing in this video, as we should be familiar with the basics of double linked list. And one more thing is, before adding the key value pair, before adding the key value pair into the hash map, we will also add it into the head of the doubly linked list. And also when it is accessed, it also move to the head of the doubly linked list, so that only which are leastly accessed will be stored at the tail of the doubly linked list. We will evict those keys when the storage is full.
Hello, I am Hemant. Today I am explaining about solid principles used in our design. Let us tell us about solid principles, how it works. And the solid principles are five essential guidelines that enhance software design and making code maintainability and scalable. First solid principle is single responsibility, which states that a class have only one reason or responsible to change. In other words, we say that each class have specific responsibility, like eviction policies and double English and storages. In our we use it in our code. Second one, open and close. Open close states that the software entities like classes, modules, function should be open for extensions and but closed for modification. In other words, we say that it means that you should use able to extend class behavior without modifying our code. Third one, if we, third one, Disco substitution principle. Uh, in this principle, mainly we focus on the derived class must be substitutable to base class. Eviction policies, and in other words, eviction policies interface ensures any implementations like LRU, MRU can replace each other without affecting our code. Let's see in our code. These are the LRU functions we use it as in Java first. So this is our Lisco principle. Let's go to interface simplification principle. That the main goal is to avoid fat interface and we uh, give preference to simple and small client interfaces. Its main aim to storage and eviction policies are small and focused on their main specific functionalities. Okay, let's see. In our storage Java, as we used this type of interfaces, Java stores and another division policies. We use it interfaces. This is called interface segregation principle. Let's go to fifth, data efficiency integrations. Okay. Let's see inversion principle. It states that higher modules does not depend on smaller modules, and but it depends on abstraction. In other words, we can tell about it mainly depends on abstraction. In our code, we use this principle as cashew class as depends on abstraction like eviction policies and storages rather than specific implementations. This is our main class. By use, we have given a capacity of 3. So capacity of 3 as a cache system or cache system. So we have had only 3 entities, key 1, key 2, key 3. And we retrieve key 1, we use get method to retrieve the key 1 value. So we should print 1 by adding another entity, but we have capacity of value is 3. So by using LRC division policy, we can remove least recently used key value. So we have by putting key 4 value, we remove key 2 value like by using LRC mod division policy. Again, we print test the emissions, so get to do. But we don't have a key value two, so we get null. We have 3 and 4. We get 3 and 4. We can get one more time. We ask retrieve data key value, so we should print one. Another entity we adding. So by using LRC recently usually this key value is 3. So by removing 3 and we can add 5. So by get final state of the class system by get 3 we have get written as null. By getting 5 we should print the 5. This is we already know this is our main class. So this is our terminal and we are executing this java c main.java and java main. We are getting this our code output. Thank you for giving this opportunity. Have a nice day.